I spent the first 26 years of my life in Seattle, and having grown up there, I've seen a lot of lenticular clouds on Mount Rainier. And most of the time from down in the lower elevations, they just look like a big blob or what most people would call a cap on Mount Rainier. But this photo shows a really interesting perspective, and this was taken by my friend Sasha Visconti on Tuesday, February 24th. And she was located up near the Alpental ski area, and so she's north of the mountain at this time. So the question is, why are there two distinct layers as opposed to one blob in this picture? So if we zoom in, we can get a look at the two different layers a little more closely, and you'll notice that there's definitely one cloud here and another cloud right here. And basically what's happening is the wind is from the northwest, and so as the air moves along and encounters the mountain, it's forced up over the mountain. Now, this isn't an exact science, but by my estimations, those layers are around 10,000 and about 13,000 feet. It's also interesting to note that as the air comes down the backside of the mountain, the cloud gets really ragged and then dries out, and there's no cloud downwind of the mountain at all. So let's examine why there are two distinct layers on this particular lenticular set. So if we look at the sounding from Quileute, Washington, which is up on the northwest Washington coast and is about 150 miles to the northwest of Mount Rainier, we can get an idea what's going on here. So the red line on this shows temperature going up through the atmosphere, and the green line shows dew point. So where the two lines get closer together, there's more moisture. So for example, in this location here, there's a little more moisture, there's a little bit more here, and then there's a lot of moisture aloft, and it's basically saturated down in the low levels. We zoom in on this and pick on a couple of particular spots here, like this one. That shows up at around 9,000 feet, 724 millibars, and the second level is around 610 millibars, or about 13,600 feet. So if I show this sounding next to the picture of the lenticular clouds that we looked at earlier, you can see that those levels line up pretty well. So whereas the middle level here is pretty dry, and when it's forced up over the mountain it doesn't really condense, these two levels that have higher moisture are being forced over the mountain, and they are becoming saturated enough to form cloud. So I think that gives us a pretty good explanation of why that occurs. So let's just zoom back out and look at the beauty of the picture. And thanks again, Sasha, for sharing this photo with everyone.